Well, good morning, everyone. It's kind of amazing to be back. Angular Connect is back. I can't believe it, right? I was sitting here somewhere in 2015 or 19, I don't remember. But, listening to this talk, so be back here on the stage and just sharing stuff around Angular, feels very special. And I guess the timing for this conference is just absolutely perfect, right? Because there are so many things happening on Angular. We've been through this Angular renaissance and just kind of doing a lot of changes to the framework itself, but at the same time, we are facing this ginormous shift in industry. So, well, perfectly timed. Now, so let's talk about the Angular. And I guess at this point, you kind of get used to our flow, our kind of well-oiled shipping machine, right? A few years back, we decided that we want to share our design or research or experiments very early with the experimental APIs, right? So we're kind of releasing early, often with RFCs, and then kind of iterating on this design with you. And when we were feeling somewhat confident, we're saying, oh, hey, this is developer preview. Normally it's fine unless you find kind of, weird stuff in the APIs. And then we would kind of iterate on that and then stabilize. So with this kind of there was a steady flow of new features. And so look at what happened recently. So in 2015, we stabilized, well, some heavy hitters really, right? The list is just massive building blocks, zoneless, right? I just can't believe that we are marking this as production ready, right? This is a project that we sometimes well, zoneless, kind of nice, probably impossible, right? And we are sitting here and looking at zoneless as production ready. On the reactivity front, we've got Effect. This is kind of all the well-known friend, I guess, at this point. And it took us some time to stabilize it. Well, because the timing of Effect is actually tricky. It's settled now, so it should be fine. My incremental hydration, right? Little feature, this amazing new capability of the framework that lets you ship applications that have this excellent user experience. They feel faster. Without much changes to your code base. And finally, hybrid rendering in SSR, where you can split per route kind of decide on the rendering strategy. So massive changes that are now stable, and just go and use them.
Yeah, and some very big features moving to stable, but even smaller features can make a big difference. And we've had a number of those, what we call the quality of life improvements over the last year. So directives and bindings now can be added to dynamically created components. We made some type checking changes, both to event.target. Host bindings are now type checked and have proper syntax highlighting. You can bind ARIA attributes without the attr dot kind of magic escape. And then you can finally use form arrays at the top level of form. And that's just a few. There are many more here that we couldn't fit on the slide.
Yeah, and on the tooling side,
they'll bring it in.
Okay. Yeah, on the tooling side, we've made some really significant improvements on the HMR side, just getting really excited to finally have that on by default and actually have really quick build and edit workflows that are just so smooth, so nice to be able to work with. On the dev tool side of things, we've had a really great year these last 12 months or so. We've got signal visualization in experimental, giving you a nice view of your reactivity graph, how these signals relate to each other, easy way to be able to debug things, as well as router visualization to be able to understand your entire route tree, how these routes relate to each other, how they get loaded, metadata about them, have really easy visibility into that. There's also, we have support for defer now, so you can see what state each of your defer blocks are in, what content is underneath those, make that really easy to work with. As well also as the, outside of Angular DevTools itself, we've added in Chrome DevTools in the performance panel, we now have an Angular track in there, so you can actually see how your Angular app's performance contextualizes inside of the broader state of your web application. So we've made a lot of really good improvements on the tooling side. We want to make sure we have something really smooth and just the ideal developer experience for Angular developers everywhere.
So lots of things landing, amazing. There's some pretty exciting stuff in the pipeline as well. Especially exciting to me, right? Signal forms are happening. Forms are getting a huge update. Yeah. We have a decade of experience now with both template and reactive. And we're finally bringing them together and adding the power of signals. Still, of course, a work in progress, but you can try out some of the early APIs if you start using the next releases. Another area of the framework where we're seeing some real paradigm-shifting changes is our animation support. Back when Angular Animations, the package, came out, browsers had kind of minimal support for this, but CSS has come a long way. We can rely a lot more on the platform now. And that actually makes your animations more performant and allows us to support them with a lot less code in the framework. Very much a win-win situation. And finally, we're continuing to experiment in the unit testing space with our experimental v-test support. We're really excited to see where that takes us. And there are also some promising new designs that haven't quite made it to the level of code yet. You might have seen some conversations about these in issues or in blogs or things. These are some more speculative projects, but we're still excited. They have some real potential. As Pawel said, we're continuing to ship on a regular basis, and we could fill this whole hour with all the recent additions to Angular and our roadmap. But of course, we have to talk about the robots. AI is transforming our industry, how we build software, how we write Angular code, the applications we're building, and perhaps even Angular itself. And I will be the first to admit, when this started happening in the last couple years, at first I was not really that impressed. I saw demos that had a lot of promise, but I was still pretty skeptical that AI could really replace a lot of the work that we are doing. Don't tell Sundar. Lately, though, I've started to really feel some of the potential. And I often describe it as it feels like I've gained some superpowers. And I remember back, even those days dressing up as a computer, right? Feeling that joy of programming, of being able to express my intentions in instructions and seeing the computer faithfully following along and executing. And I still feel that today, both in the work that I do on Angular and the coding that I do for fun. But there are aspects of every project that aren't so joyful, right? That feel like pure friction or tedium. You know what I mean? Like, you know what you want the code to do, but it feels like you have to do 10 different things along the way just to get there. All of those unrelated tasks that just slow you down. And for me, this is what AI has impacted most in my workflow. Whether it's the auto-completion that feels like it's kind of reading my mind and a little bit ahead of me, or just tasking an agent to do something that I don't want to do. I feel like I can spend my time focused more on the code that's actually important, the kind of core logic that I'm trying to get right, and leave the boilerplate to the robot. For example, in my free time, I actually like to write mods for games. And often that involves working in C# in the Unity engine. But if you know me, you know my heart lies with Rust. And I always dream about combining these two things. I want to be able to use Rust for some of the projects that I have within that C# world. And I've never really been able to reconcile this until I was on the bus a couple weeks ago and had this idea of how to pull this off. What if I embedded WebAssembly in the C# world and used that to bring Rust into my code base? Now, I know a little bit about WASM, but I've never done anything like this. I've never embedded it inside of another environment. And ordinarily, that's the kind of idea that I would think, that's interesting, but I don't have the hours and hours of research and kind of free time that it would take to figure this out. With AI, though, I thought, why not give it a try? Let's see where this goes. So I was able to kind of talk through with the agent a little bit of some of the options, kind of figure out an engine that would work well, and have it wire it up in my project. And I expected on this bus ride that I would get home and spend a couple of hours maybe trying to get this to work. Instead, by the time I got back to San Francisco, it was actually running. That was an amazing experience, right? I could then use my free time at home exploring what I could do with this thing rather than building all the infrastructure.
Yeah, and that's a really interesting story on this. I've kind of been using AI a little bit of a different way, where I recently was writing a blog post, and I kind of wanted to get a sense of maybe where there were some weaknesses in my argument, where I might have made some mistakes. And so I fed it to an AI and asked it to review this blog post before I published it. And I told it very explicitly, you are a Hacker News commenter who absolutely hates this blog post. And I want you to explain all the reasons why it's awful, all the arguments that it's missing, anything that you might want to consider there. And so it was able to give me, a bunch of feedback about it for things that I might have overlooked, and give me a chance to be able to respond to some of the more reasonable arguments in there.
It actually came up with some reasonable arguments against your idea?
Oh no, there are no reasonable arguments in Hacker News Commons. But it was a great idea in theory. Yeah, and so on top of that, I struggle a lot with generating UI from scratch. I don't know if it's just something with the way my brain works, but like I can kind of visualize the higher level concept of what I want, but I really struggle to fully pull out the fine details of that. So I can envision a button, but it's really hard for me to know, like, what does the press state look like? What is the coloring on this? What exactly does that look like in my head? I just struggle to visualize that. And so I found AI to be very useful, in particular, to be able to kind of scaffold out a UI from scratch, to be able to give me a starting point. Maybe it's not perfect, not exactly what I want, but something close enough that I can have somewhere to iterate from, something to play with, and kind of help overcome that writer's block at the beginning of developing a solution. I found it to be really helpful.
Wow, those are great stories. Thanks for sharing. And I guess like those aha moments with AI kind of came in different forms and shapes and different times for us. And for me, it was just kind of using LLMs as the AI team design. Like a lot of the stuff I'm doing on the Angular team is actually designing new concepts, new APIs. And recently I was playing with the pipeline that I would call like LLM-driven design, really. So the idea is that like before you like design the API in full, you just kind of like write documentation and try to use it with like, you put lots of examples in the documentation. And again, without any code written to support those APIs, you just feed it to LLM and say like, hey, write me like applications with this, like components, like lots of them, like hundreds and hundreds. Right? Like, and it turns out that LLMs are like pretty good at using the language that you just invented, right? Like they haven't seen in the training set. So they are like pretty successful generating code for the APIs that kind of don't exist really. So that's good, but like the more interesting part is how the LLMs are failing on this task, right? Like they will actually find inconsistencies in your design. They will like, oh, maybe this API is confusing, or maybe this API is not flexible enough, and they will kind of fail in those places. So then you can just iterate on your API, iterate on your documentation, and at the end of this process, you are ending up with something pretty good, right? So I guess we are essentially coming here and saying, well, we're kind of pretty excited about this technology, even if we're pretty skeptical at the beginning, right? And it's kind of funny, like yesterday I was walking back to the hotel from the speaker dinner, and Miles, a colleague from the team, was asking like, hey, were you asked to put so much AI content in this talk? I was like, no, actually no, we're just kind of so excited about the potential here. So I guess we kind of took this, energy and excitement. We've got a new toy in front of us. And, as Angular developers, we started to try it out on Angular applications, right? Like many teams at Google tried this, and I'm sure you also tried to write Angular with LLMs. And here we've got example of Gemini Canvas writing a perfect Angular application, right? Like it uses the modern APIs, it uses the right design patterns, it's not tipping over common mistakes that you might have, just perfect outcomes. But what was interesting to see that these outcomes are very different depending on the tool you are using, right? Like some tools I would say, hey, write me an Angular application, and I will get APIs from several years ago, ng module here and there, and ngIf maybe. Or I would go to other popular tools and say hey, I want Angular application, and in response I would get a React one, right? So that was a pretty confusing moment, to be honest, and we were asking ourselves what's going on here? Is it what parts of the pipeline explains this difference between different tools? Okay, is it that the different tools are using different models, and those models were trained on different frameworks? Or maybe this is part of the workflow, or maybe this is prompting. It was really not clear what's going on. But as being engineers that want to understand what's going on, we built ourselves a kind of isolated lab environment where we could exercise those prompts in isolations. So essentially, we built something that we call LLM Evals tool. And what it does, it shoots prompts directly to the model, by passing, all the tooling and layers that might have been added, and gets applications back. Right, so here's the example of a prompt. Those are like 2 or 3 sentences and kind of UI that is, like generated when this application is running in a browser. And so we did a lot of like silly things, some kind of things that are more representative to the components that you would be writing every day, and so on and so forth. And we generated, like, I don't remember like the exact number, but there are like hundreds of those prompts. Now, when we've got them, we will, go to the models and like generate those applications. The code would come back, and then we would do all sorts of checks on the code that was generated by LLM. So we would start with basic, like, is the code compiling? Is it passing all the lint checks, and so on? Can we build it? As soon as we can build it, we would load it up in a browser, see if it functions properly, like we would see if there are no runtime errors. Then we would take a screenshot and see if this, like, visuals are good. We would run it through like accessibility checks and so on and so forth. Lots of checks to, in the end, get us like one number, which would say like some sort of quality score for LLM-generated applications. Now, we look at the scores for Angular applications in this lab environment, and the numbers look pretty good. Honestly, like they were really, really good. Right? Like 99 of applications would compile and pass all the compilation checks on the first try, like a single shot generation. Of those applications that would compile, again, around 99% would run perfectly in the browser, like function properly, no errors whatsoever. And, well, if you ask me, those are pretty impressive numbers, because LLMs are kind of not deterministic by very nature, yet they are able to follow all those instructions for Angular properly. So I guess the biggest takeaway here is that LLMs are really great Angular developers, right? Like they should be absolutely part of our community. They should be like given Angular t-shirts and sitting here in the audience. And obviously they are not perfect, right? Like they will, from time to time, they will put ngIf in the generated code or make a hilarious mistake. But I guess that's okay, because this is what we do from time to time. Now, this little tool, this lab environment, helps us understand the very nature of the generation pipeline. And we believe that this tool can be used by Angular, but also by other frameworks and library authors to understand how the APIs are kind of like cooperating with LLMs. And to this end, we started to partner with some frameworks. For example, we did chat with the Solid folks, and they plugged their framework into the tool, and they are seeing similarly great numbers. And, like we are curious minds, so we obviously plugged other frameworks in this tool. We are talking to different teams. But let me tell you, those results are probably the best we can get. So we've got like so many other ideas for this tool, and kind of want to take it further. Again, both for us as the Angular team, but for other communities as well. And we will be sharing more on the YouTube event that is happening in, I think, three days from now. Okay, so coming back to this, 99% of correct generations results, this is great to have those scores in the kind of like controlled laboratory environment. But it's interesting to kind of note how we did get there. Like, we didn't start with this score. There's also an interesting question of our experiences that might be very different from those lab environments, right? Like you might be trying a different tool and getting different success ratio. So what is the secret sauce here? Like how we get to those good generation numbers? And the part of the secret here is really a system prompt, like something that we like when we type into chat, or like LLM chat, a prompt, we might be kind of assuming that this is the small part that is kind of going directly to the model and is kind of being understood there and followed. But in practice, what's going on, that every tool has kind of embedded and configured so-called system prompt. And those system prompts can be huge, right? Like, I mean, I'm like thousands lines of text, huge type of thing. And those system prompts will go into the, like, well, they first of all, they will mention a target framework multiple times. They will go into define details of the best practices to follow for a given framework. They will mention third-party libraries that should be used. They will talk about how CSS, like which CSS kind of library should be used and how, and so on and so forth. And those system prompts have like a dramatic effect on the final generation results. And it's kind of very hard for user to override the instructions of the system prompt, right? Like this is just like small pieces of it. So creating a good system prompt requires this substantial work and iterations over time, right? The LLM eval tool help us to iterate over many tries of the system prompt to get to this excellent generation results. Then we partnered with several teams at Google to embed this kind of fine-tuned system prompt in different tools, right? Like, so some of the tools, like I've mentioned Gemini Canvas, it will, for example, automatically recognize that we're asking for Angular and kind of plug a system prompt for Angular. For some other tools, you have to kind of, use the configuration or like drop down here to say like, oh, I want specifically Angular. Some other tools will pick up, desired settings from some files that you've got in your project directory. So what we are starting to shipping from version 20 is that the new ng-new command will kind of scaffold configuration for LLMs so they know that you want to use Angular with a given system prompt. And if you happen to have existing project, you will go and just do ng-generate AI config and this kind of like, add those configuration files for the existing projects. Now, there are kind of more details of system prompting and configuring those for different tools. And we kind of try to get all those instructions on Angular Dev AI. So just go there and, configure your tools.
Yeah, so there's kind of as Pawel was mentioning here, right? The code gen is only a very small part of the problem or the challenges that come with AI. There's ultimately a huge spectrum of scale and complexity that AI agents can work with. A lot of the initial AI tooling today is really focused on what I would call the initial spark of creation, right? You're vibe coding to spin up a new prototype or a simple application, you modify it a little bit, gradually add a little bit of functionality, but it's relatively short-lived. We tell the AI what we want, but both the implementation and often aesthetic choices are things that we're intentionally leaving up to the whims of the model. At the other end of the spectrum is sort of what we've taken to calling precision engineering. This is where you're maintaining and evolving mature applications that are sort of central to your business needs. And this takes a lot more than just good code gen. It's why we call ourselves software engineers and not just coders. Building scalable software is really hard. Working in large established code bases takes an entirely different set of skills than just writing code. And so it's no surprise that a lot of today's AI tools struggle to reach this scale, especially those based around these kinds of vibe coding prototype workflows. And that's ultimately okay. The ecosystem is pretty new after all. We're all still experimenting, trying things out. And right now we really are on the cutting edge of what's possible here. And it's exciting to see these things, getting better each and every day. Ultimately, we don't know where our industry will land on this spectrum. But what we do know that we'll end up somewhere, maybe even in multiple places for different use cases. And we want to make sure that we position Angular so it can be prepared for that future. But ultimately, we think that the recipe here is actually pretty clear. In order to succeed at more complex precision engineering workflows, we need two main ingredients. We need a capable, scalable workflow and a way of feeding the LLM the right context to accomplish a task. And both of these are pretty challenging problems in their own right. But let's just start with talking about the workflows first. So AI is exciting for a lot of reasons, but what we're witnessing here is kind of the birth of an entirely new ecosystem of tools and integrations. And ecosystems, they evolve and change over time. This has been a recurring thing. We've seen the Node ecosystem move through a lot of growing pains into ES modules, or how Rust and Go code has found its way into all of your tool chains. But it's really quite rare to see a new ecosystem just kind of created in real time in front of us. The basic foundational primitives, libraries, tools that we use to build this ecosystem are still in a state of flux. We really haven't standardized on those yet, much like the early node ecosystem, if you're around and remember that. We're still trying to figure out the right ways to manage just complex prompting files. Model Context Protocol, or MCP, it's a core building block for developing AI tools and adding capabilities to agents. But that's less than a year old. Like, what even is time anymore? I don't know how to manage this. So, Angular needs to fit into this ecosystem, but exactly where is kind of hard to nail down, and we need to have some visibility into that. As an industry, we're pretty used to developing tools for humans, like the VS Code extension or Angular Dev Tools. We also know how to develop tools for automation, along the lines of like Angular CLI, which you can run in a CI workflow. You can automate deployments. We understand how to make those things work and what tools and systems we have available to solve those problems. But now we have an entirely new user profile in the face of AI. AI agents have many of the same needs as these other two user types, but they have a completely different way of interacting with Angular. And this is a unique challenge for the entire software industry. We need to reevaluate all of our assumptions about, what it even means to have a well-abstracted user interface, and consider what new tools or interfaces are needed to meet these new requirements. And as one example, we've seen AI agents struggle a lot with ng-serve and ng-test as well. These commands both run forever. They just sort of sit there in a loop, which has been fine historically for humans, right? We know you run ng-serve and it just runs forever. AI agents struggle with that. They want it to complete and then move on to the next thing. And so it just kind of hangs there. Sometimes I've seen the AI will actually look for the dev server I'm already running and then kill it and then start its own dev server and then hang. Come on, bro. Okay. So, it's just, there's no good way to recover that. The prompt's just, it's totally destroyed. And, sometimes I've seen the AI will be smart enough to run the dev server in the background and, at least that doesn't hang. But then it's completely detached from standard out at that point. It can't see any error messages. It doesn't know if anything's gone wrong. And that seems problematic too. And so, we're trying to recognize cases like this where, our tooling just, historically ng-serve was fine, but now with AI, it suddenly has these challenges, and we want to see what we can do to try to evolve this. And we're looking into ways to make that more effectively manipulate Angular CLI. Another challenge is new APIs like signal forms. You all excited to use signal forms? Yes. Yep. So, Alex and Miles are going to give a talk on this later. I don't want to spoil too much of that. But the signal forms presents a very unique challenge in the context of AI. Typically, when we release new features, we write some docs, we publish some videos, do a few conference talks like the one later, do some Q&A, and largely the community takes it from there. You all write these amazing blog posts, you help people on Stack Overflow, do video breakdowns, you build common solutions for recurring problems. They're just like one layer of abstraction above what we offer out of the box. And that's all super powerful, and that's what feeds these AI tools to be able to understand how to use these systems. But ultimately, AI doesn't work on that same timescale. Training AI models takes time, and it requires that sizable corpus of content to learn from. And so it means that on launch day for something like Signal Forms, AIs just don't know how to interact with that, and they don't know how to write that code. And so this forces Angular into a situation where we sort of have a very real pressure not to change and not to do these kinds of features in order to remain compatible with all of the AI models out there that have already trained on this existing Angular code. But ultimately, we don't want that to hold us back. We don't want that kind of limitation preventing us from evolving the framework. And if AI is critical to your workflow and a new stable feature is launched, like Signal Forms, but then it's not known to your AI agent and can't generate that code, is this feature really released? Is it really available to you? Some deep philosophical thoughts right there. So we've been experimenting with an MCP server inside of Angular CLI, sort of exposing some of this unique Angular-specific functionality to AI agents. Right now, this provides a few tools around providing Angular best practices and documentation search to make it easier to inform AIs about these kinds of features. But beyond that, it also includes comprehensive documentation on new APIs that AI models might not be trained on. So to take the Signal Forms example, we have some high-level examples of how to use Signal Forms with clearly defined context and purpose to kind of help guide the AI to when it wants to reference these kinds of examples and use them as part of its code gen story. This includes concrete samples of like actual code snippets of what this looks like. And so even if the AI model has never heard of signal forms before and has never seen this in any capacity, it still has the fundamental information it needs to be able to generate and interact with this new system. Now, ngserv and signal forms are just kind of a couple of immediate issues that we found with AI agents, but the problem is a bit more foundational. So have you ever been in a situation where you ask the AI for help with a problem, only for it to then come back and ask you to copy-paste whatever it is you're doing, right? This, you can pretty easily fix that, just paste in what's there. But ultimately what this is indicative of is that the AI doesn't quite have the knowledge or capability to solve this particular problem. And it needs to rely on you as the human to fill in this gap. And so there's a broader problem here than any one specific bug. And this is something that I'm kind of thinking of as a capability gap. And one guiding principle that we're exploring is that any capability a developer has, an AI agent should have as well. What that means is that any action a user can take with respect to Angular could be as simple as writing some code, could be starting a build, could be checking the state of a signal at one particular time. All of those capabilities should be available to AI tooling just like it's available to humans. Now, this doesn't necessarily mean there's no limitations on it, right? Don't just run a prompt and then push it to prod. But the idea here is that humans and AI agents should generally have parity across their raw capabilities. And I personally say this quite selfishly because anything that the agent can't do is something that I need to do for it. And it just becomes a chore, one more thing I need to deal with. And if the AI can't read an error message, it falls on me to copy paste it. And I just don't want to do that all the time. I don't want to be a gopher or a mechanical Turk for my AI. You have to keep the AI in its place, okay? It works for you. So what exactly are the capabilities that AI agents need? As we've explored the space, we've noticed that humans and LLMs have drastically different mechanisms for interacting with a system like Angular. But the two actually have very similar core needs. They both need to compile an application. They both want to read error messages. They both want to inspect application states. There's actually a surprising amount of overlap between these two sort of user types. So that begs the question, what are the core needs of an AI agent? What problems does it need to solve? And ultimately, this comes from the specific workflow that you're trying to use. So let's examine sort of how exactly do you as humans develop software? How do you build features in your day-to-day workflow? Now, like most programming concepts, we can express this as a loop. So you start your dev server with ngserv. You write some code that you know is definitely, absolutely, certainly going to work on the first try. You wait for your build to finish, takes a little bit, and then you test your application in the browser. You look at your styling, you click the shiny new button that you just added, and then inevitably it doesn't work. You knew it wasn't going to work. You lied to yourself again. But you then have to debug. You have to figure out what's wrong, start analyzing the runtime state, try to figure out what a potential fix might be. And then ultimately you loop back. You try again. You write some more code. You go back, test it again. It takes a few tries. You loop around. But eventually you get that passing test. You have things working. Now, this is a simplified graph, right? And it's obviously missing critical nodes like making coffee or fix CI or waste 4 hours configuring your dot files, things that happen every day. But this is ultimately, it's hopefully a reasonable model for sort of examining how software gets built. And since we said that AI agents should have comparable capabilities to humans, can an AI achieve this same workflow? So let's try this again, but from the AI's perspective. Okay? The AI wants to start a dev server with ngserv. Now, I mentioned that that currently hangs, but this is fixable. We can maybe add this support to Angular MCP, something like that. So hopefully we can fix that. Then the AI generates some code. We spent a bunch of time talking about code gen and how it turns out AI is actually pretty good at that. So we're doing okay there. Next, the AI needs to wait for the build to finish. So this isn't too complicated, but it does mean it needs to connect to the dev server. It needs to be able to know whether a build is active, be able to wait for that. Next, the AI needs to test the application in the browser. But how exactly can it do that at scale? So at this point, I'd like to pivot a little bit to talking about Playwright MCP. If you're not familiar, Playwright's a browser orchestration tool for manipulating and controlling a browser instance, typically used for end-to-end testing. But Playwright MCP makes the same capability available for an AI agent. I've been experimenting with this and found it extremely useful for testing my code in a browser. It seems surprisingly good at sort of formulating test cases and exploring an application. Also serves as a nice sanity check for accessibility because the AI is not going to click a button if it doesn't realize it's a button. So that's kind of an extra incentive to make sure that you've got semantic HTML and that kind of thing. It's also just really cool, frankly, just seeing an AI drive browser. So if we have Playwright MCP to kind of fill in that bottom gap and help us test an application, where does that get us? This provides the AI with a very simple pass-fail signal. of whether or not it has succeeded at its task. But ultimately, this goes beyond that. The AI starts a browser with Playwright MCP, it clicks the shiny new button. Maybe it doesn't work. It observes that this button didn't do what it expected. So what happens next? Well, the AI agent still has access to the browser. And this gives it an opportunity to expand this fail signal with additional context and understanding about the problem. The AI observes the page itself, it checks console errors, it looks at the DOM, it screenshots styles, tries to see what might be happening, and it has access to all of this. But this runs into our next problem around sort of all of the application logic that you have in your JavaScript. How does the AI have access to that information? You have a sea of JavaScript objects out there. How does the AI know which one of those has your bug and how to address that? Well, for emulating a human workflow with this process, how do humans solve this problem? And the answer here is Angular DevTools. You open up Angular DevTools, you have a nice view of all the hooks and visualization in your application. You can see the internal state of what's going on here. You can inspect components, you can see the dependency injection graph, the signal graph, you can see all of this stuff really easily. So if a human can open up DevTools and check the component state or DI graph, how do AI tools do this? Well, I've been experimenting with a new MCP tool to try to query a running Angular application and extract that same runtime data that you normally get from Angular DevTools. Here, I'm asking the application to provide the dependency injection graph, which is a piece of information that's really only known at runtime. You can't get this through static analysis. And it doesn't quite visualize the same way that humans do, right? I want to see boxes with arrows between those. That's the thing that makes sense to me. But AI does, visualize in its own way. It's an LLM, it takes text, but this is kind of what that might look like as a more visual form that makes sense to an AI. And so now when you get something like a dependency injection error, the AI can use this logic to try to figure out why that might have happened and what it needs to change to fix it. So how does this really work? The way I have this set up is that the user gives the AI a prompt. And then if the AI decides if it needs more information, it can ask Angular CLI's MCP server. This connects that to the running dev server instance that's already happening in ngserve. And it communicates with the Angular application running inside the browser. And it's using the same APIs under the hood that we already have for Angular DevTools. So pulling that same information about the application. So we plug this in, and we've got this into the workflow, and we finally we've enabled AI to debug Angular applications. And we've kind of completed this loop, right? We can, at least in theory, go all the way around it. We've got each part of this human-centric workflow. And this sounds great in concept, but is this actually viable today? So, are you all ready for a demo? You see this? So, I can help Alex. Okay, I need to try to time myself with this. So, we've got an Angular e-commerce application. You might have seen a little bit of this. Sadly, not real, I know, but it's not super complicated, but it's far from trivial and hopefully large enough to be an interesting demo. I've added some wish list functionality. So in the bottom corner, we got a little star there. Hopefully, when you click that, it would add it to a wish list. And there's a button in the top right to be able to view your current wish list. I've also scaffolded out a service as well to manage some of the state, all with AI. Now, what I'm going to ask Gemini to do is to fill in some of the last piece. So I'm asking it that to essentially, when this star button is clicked, add it to or remove it from the existing wishlist service. You don't need to worry about the rest of the prompt, nothing to see there. So it's going to do its thing. Don't worry if you can't read the specifics on this, because the specifics aren't too important. But the idea here is Gemini starts doing its thing. It analyzes the project. It proposes a fix. What it's really doing is it's just generating some code to call the wishlist service, and what it's doing is pretty accurate. It's exactly what I would do. It starts up a browser with Playwright to actually test this out. So it starts driving the same test case. It goes down to the wish list, clicks the button, exactly the way I would expect, and then it goes up to click the wish list button at the top and sees, in a moment. Oh, I skipped that. Didn't work. Didn't work. That's the point that comes there. So the AI starts to figure out, like, hey, this didn't work. Let's see what's going on here. It actually inspects the Angular's dependency injection graph and notices that the wishlist service is actually exposed in multiple locations in this dependency injection graph. So it sees that there's potentially some risk here. And it notices that, hey, this might be a problem. You might be splitting your state across multiple wishlist services. That could be a problem. So it proposes that maybe there's correct solutions to try to consolidate this into one location. And so here it makes a bunch of edits. Again, don't worry too much about the specifics. It's really just moving providers around. So getting rid of some old providers, moving them to the application config, trying to consolidate on a single location. And then it checks the DI graph again, and it sees, hey, we've removed all those extra wishlist services. So we've got one service that now exists for the entire application. And so then it refreshes the browser, tries again, does the same test case one more time. So again, zooms in on that star, clicks that, goes up to the button at the top, and gives it one more try. Building success, the building suspense, that's what I'm saying. And boom, got it. So it has now fixed this issue. It's got in the wish list, able to actually see the shirt. It even clicks the star again just to make sure that clicking it removes it from the wish list. So it's smart enough to make sure that it does this. And I didn't tell it to do that, by the way. I didn't give it a test case. I didn't explain any of that. It just figured out that whole test case. So I think this is super cool. And to recap here, right, we've gone through this whole loop in the AI. It generated some code to add this thing to a wish list, tested that code with Playwright, found a bug, and that bug had no error message or anything obviously wrong. It just didn't work. And I want you to think back for a moment on like when you've been in that situation where you call the function to add the product to the wish list and it just doesn't work. You know, how would you might tackle that problem? How would you approach it? In this case, the AI came up with its own idea. It debugged with Angular's DI graph, figured out what might be the issue and proposed a fix, and repeated the loop to test again. Now, this experiment I've kind of got set up with Angular MCP, but there's also a very recent proposal for Web MCP, which would essentially allow JavaScript tools to define their own MCP-like tools in the browser directly. We think this would be incredibly powerful to make it even easier for tools and libraries to provide these kinds of debugging utilities out of the box without necessarily needing to ship their own MCP server in the way that Angular does. And we'd be able to integrate Angular's functionality here with any AI features in the browser itself. So if you use Chrome AI Assistance and you want to be able to ask that about your dependency injection graph, it should be able to answer the same way. So we're very excited about this proposal. We're hopeful that something like this could make it even easier for AI agents to consume Angular's runtime data within the browser. Now, ultimately, this workflow is still in a very early concept stage, right? And that demo had a lot of caveats to it. But I think it highlights a potential future that we can strive towards and use as a guiding light for potential Angular integrations. But honestly, I don't think this approach is that far off from reality. AI agents have come a long way in a very short amount of time, and they will likely continue to improve. And this workflow is heavily simplified, and there's a lot more that the agent might do. The AI should probably have access to your build errors and be able to loop back and fix some things there right off the bat. It should participate in automated testing as well. You know, it's not just running up a single test case in your browser, but actually generating something that's a little bit more reproducible. Sometimes you need to insert yourself, right? You need to talk with the backend team and figure out why their API is broken yet again. And sometimes you just need to step in and write out a little bit that the AI is having trouble with. It happens. So you're not necessarily going to run the AI in this full loop every time, but you're going to be using parts of this as your workflow requires. But what's interesting from Angular is that supporting this whole workflow means that the AI can still collaborate with you on the individual pieces for whichever parts that may be. The idea here is not so much that Angular prescribes a specific AI workflow. We're still in the very early days of AI, and we don't have a ton of confidence that any specific workflow is going to be one that everybody's going to use. But the idea here is that we can provide the relevant primitives on the Angular side to make sure that we can support any relevant AI workflow that you might want to use.
Oh, that was cool, huh? I love seeing the AI go through that whole workflow. Yeah. One of the most important lessons I've learned about AI this year is that the capabilities, like the abilities of the model themselves, are very distinct from the abilities of the systems we build around them. It's really those systems that are going to take us to that next level. And Angular is fitting pretty nicely into the ecosystem of tooling around MCP and LLM workflows, even though we've clearly still got a lot of work to do. But let's shift our focus now to the other half of this equation, right? Ensuring AI agents get the right context for the tasks that we want them to do. And as humans, we're pretty familiar with this. We develop experience working in a code base over time. We know how it's organized. We know what design patterns it's using. And we know the not so good parts, right? We know things that are fragile or broken. We know where the technical debt is, the history of kind of why something might behave the way it does. And generally, when you assign us a task like add interaction logging to the signup flow, it's that experience that lets us know, oh, I need to go to this part of the code base. It's these files that are relevant. I have to be careful when I'm editing this object because it's shared with another part of the system. We're aware of which parts are central and more load-bearing and which parts we can easily replace. And more than our ability, our raw ability to code, it's that familiarity and expertise that we've built over time that context that allows us to function as the code base scales up, as the application gets bigger and more important. And we bring that context with us into every new feature that we build or every refactoring that we undertake. How many of you have had a junior developer come up and show you an error message that's just completely cryptic, right? Hieroglyphics. And you look at it and you know instantly, oh yeah, it's that thing from 2 years ago that we never bothered to fix. I know what's going on here. Like just, add these 3 commas and it's fine. How many of you have been that junior developer? Yeah? That's context. And if we want AI-powered software engineering, right, precision engineering that scales beyond greenfield use cases, we need more than excellent code gen, and we need more than workflows that bring our capabilities to the AI. We also need to give them the same understanding of the code base that we enjoy, the same context on how things work and why. And this is where we think Angular actually has a pretty significant advantage. We've always had this opinionated nature. We've had strong conventions around the structure of the application, patterns around data flow and dependency injection. And when we hear from you, our developers, you tell us it's actually fairly easy to move between Angular code bases for these reasons, because things feel familiar, everything's in the same place. And we think this is a property that's going to pay off significantly in our AI era. So we've been asking ourselves, can we standardize even more? How can we leverage this structure and help AIs kind of navigate and find their bearings in our applications? And developers are already using conventions for this, right? You have patterns around data flow and everything in applications that aren't a part of the core framework. Can we promote those? Can we give them first-class support? Can we use them to teach AIs how to reason about Angular code? And it goes beyond just whether something is correct or not. It's about ensuring quality as well. We already use in Angular structure and what we call guardrails, things like extended diagnostics, to keep developers on happy paths of performance and accessibility and security. And we think that approach, not only will it work well for AIs, but we might want to lock it down even more. We may want to have toggles that will just prevent an AI entirely from calling bypass security trust HTML, at least unless I kind of give it a permission slip, right? I don't want it doing that in the middle of a 1,000-line PR without my approval. Right? Make it impossible for AIs to write kind of slow-performing code. So we can build MCP servers and context systems and everything I've been talking about for the Angular of today. But I think it brings up an even more fundamental question. What does this mean for Angular's future? How will Angular itself be shaped by this new ecosystem, this new reality? We're at the dawn of an era in software where AI becomes foundational to our development lifecycle. And so as we evolve Angular, our focus is going to be on weaving that intelligence directly into the framework's core. We want AI and Angular to complement your engineering skills, to multiply your productivity. And we're already seeing the impact of this on our team. For example, what Pawel was talking about earlier and the way we think about designing APIs. We found LLMs to be a pretty excellent tool for measuring the quality and developer experience of our API designs. We did this before previously using user studies, right? We get feedback from genuine users in a controlled and repeatable environment. And that's a time-consuming process. We'd have to do the design, build a prototype because people need something to play with in order to get real feedback. We'd have to write a study protocol, a very formal specification of what we want to ask them, what resources they have available, how long we should give them for tasks, what feedback we want to collect. We'd send that to an agency who would go out and find a bunch of developers who matched a certain criteria, certain experience level, and so forth. And it would take weeks, and they'd come back to us and give us a big report on how well the API did. We did this for signals. We did this for control flow. And the results were invaluable. The APIs were shaped greatly by the outcomes of those studies, but it took time. It took weeks. And with LLMs, that feedback loop closes now to hours. We can start with an idea, then we write documentation for it. We don't actually have to build a prototype. LLMs are happy to write code against APIs that don't exist. Sometimes we struggle to get them not to do that. And we often do this documentation anyway because that's itself a good way to explore the quality of a design. Can you explain it to someone? And we feed that doc to the LM and ask them, go build applications, right? Hundreds of applications. Go generate code that tries to use these APIs. And much of the time they get it right, but when they struggle, we can actually take their struggles, right? We use LMs to analyze, hey, what are the major failure modes? And we can go back and adjust our designs accordingly. And we can do multiple passes of this loop within a single day if we want. And when we started these efforts, when we started playing with these things, we wondered, do we have to change our approach to API design? Or LLM's a very different customer that wants a very different kind of API. But in our experience, that's actually not been the case. We've actually found, statistically, LLM output is highly predictive of developer friction. If a model trips over some detail of an API, it's pretty likely that a human developer will too. And that's not to say that there aren't some differences. For example, in the past, we make developer experience trade-offs that directly favor what I would call human sensibilities: syntactic sugar, convenience, low verbosity. In our testing, we see that LMs fall in a slightly different place on the spectrum. They're happy to generate more verbose code as long as it's straightforward. They struggle with APIs that are syntax sugar that aren't actually doing what it looks like it's doing, or APIs that kind of don't match something in the language that they look like. That's a trade-off we're going to have to manage. So let's look at a concrete example. This is what looks like an Angular for loop, but it's a little bit different, right? This is actually an early version of what our control flow spec looked like. We still had the let keyword, but more importantly, you can see the loop variable here is a signal, right? Item is a signal. And that fit nicely into this trajectory we had for reactivity of eventually Angular having some kind of concept of a signal-only component, a component where the reactivity was only managed through signals. And we had this in our user studies, and we saw this actually frequently trips up participants. They were expecting item to be a plain variable, plain value, just like in JavaScript. And so recently we wondered, would LLMs actually hit the same problem? So we tested the syntax. In our prompt, we gave the LM examples of for loops where the loop variable was a signal, and most of the time it was able to figure it out, but not always. We were never able to completely eliminate that as a source of error. And we've seen a number of examples like this where LMs are tripping over the same things where we know our APIs would be confusing to a human. In fact, of all the quality of life improvements that we talked about, half of them were directly inspired by our work tuning Angular code generation with an LM. We test our prompts, get a list of failure modes. Some of those failures we could solve by adding better examples, improving the prompt. But in other cases, we looked at what the LM was trying to do, saw that it was tripping over the same things that are tripping up human developers, and decided maybe we're the problem, right? Maybe we actually want to change the API and just accept that this is how it should work, if that's what the model wants to do with it. And we're so excited about the potential of this workflow that we've pretty much automated it. We start with a design, like a new idea we want to test for component syntax. We did some experimentation around selector lists, for example. We then run our LM evals tool, the same one that Pawel was talking about, generate hundreds of applications every night sometimes. Some of them succeed, some of them fail. We take the failures, we feed it back to the AI, ask it to tell us what are the root causes, what are the problems, places where this goes wrong, and we actually use the model to improve itself. We feed those failures in and tell the AI, please adjust the prompt to fix these problems. And this feedback loop works surprisingly well. In fact, here's a result from LM evals, and this shows about a 95% success rate of generation. That's pretty good. It's comparable with Angular and other frameworks. But there's a trick here. This is for an API surface that doesn't exist at all. Right? What do I mean by that? Well, the LM here has never seen in its training a single line of code for the APIs that this is based around at all. We made it up completely. We started with a very simple surface. Here's an HTML template that you can render. And we asked the LM, build some applications. Turns out you can't build interactive applications with just HTML. You need data binding. You need control flow. You need some kind of components. And so the LM would try and fail. But in seeing how it was failing, what kinds of tools it was reaching for, we said, oh, it wants to do things this way. Let's add that as an API or maybe a slightly different version of it and run again. So we're using the LLM to kind of fill in the blanks in the API design. But by seeing how they're thinking about the problem and turning the mistakes into real APIs, we ended up with a framework that the LLM has never seen before, but is generating code nearly as well as things that have been in the training set for years. Right? And that's a very important result for us because it demonstrates the power of designing frameworks this way. Okay, we've talked about the impact AI will have on the way we build applications and possibly on the way we build Angular. But there's one other question that's been on our minds. AI is already kind of changing expectations around the user experiences of applications themselves. And we think that's only going to accelerate. What do the applications of tomorrow look like? And what do we need to do today as a web framework to support them, to support you in building those experiences? And I've heard all kinds of predictions in this space. Everything from all UI is going to be fully dynamic written with prompts, right? You'll never check in a line of code again. Code becomes ephemeral. All the way to the end of web browsers as we know it. Probably the reality is not so extreme. There are some things which are evident already. For example, you all know the infamous AI chat experience, right? Open up a sidebar like you're texting with the application. We hear from our customers that they're working on richer versions of this. They want the AI to answer back not with text, but with rich, immersive, interactive UI. Google Search is building entire new experiences around fully dynamic UIs that are generated and streamed by LLMs. And later on today, there's a talk by Mike Ryan, who's here somewhere, on a library called HashBrown. HashBrown allows you to generate kind of dynamic UI experiences on top of LLMs in Angular today. You don't want to miss this talk. It's pretty cool. And we'll be honest, dynamic UIs are not a strength of Angular. Our API was designed more for the pre-compiled use case. This is a space where we have some work to do. We know it. It's something we'll fix. But also, we want to hear from you. We're not application developers. We know some of you have even more exciting, innovative ideas of things you want to do, things you wish you could do in your applications. And that's why yesterday we published our latest RFC. We're asking you, what are your use cases? What are your ideas? What's holding you back from building the experiences with Angular and LLMs that you want to do? And we want to make sure we're supporting those use cases. We're supporting those features. We want to enable everything that generative UI has to offer.
Right. We should count how many times we've said AI or LLM during this.
If only there was a tool that could count for us.
Yeah.
Yeah.
So I remember, like, being at Google for the last 2 years, we're getting all those internal emails and saying like, hey, play with the AI. AI is coming. There's a new model. There's Gemini like X and whatnot. And we're like, oh, another AI email. Like, I mean, I don't want that. This is this strange technology. And we're kind of like coming to this stage and doing the same thing. So on one hand, I do apologize for like AI email, but at the same time, like it's happening, right? Like it's kind of coming in different forms and shapes. It's coming on a different time scale. Like some of the things are just like you can do today. Some will come later, right? Like so we need to prepare for this. And go play with this. It's super powerful. If you choose to play with AI specifically on Angular projects, installing system prompt is the surest and the kind of like the easiest way to have good code generation. Right? Like again, shout out to all the resources that we've got on Angular AI and all the tooling that we are trying to put in place, so we don't have to copy this 1,000 lines of like prompt into various places. As Alex mentioned, like applications will look different, right? Like people talk about the different interaction patterns, very dynamic AIs. I kind of keep talking to Alex. He's not listening to me, but I keep talking to Alex that I don't want to fill in forms on the web anymore, right? Like I want LLMs to interact with.
Even if they're signal forms?
Again, you see what I have to keep up with? So yeah, like just kind of go to this RFC because we know that there will be new interaction patterns, but we are not application developers ourselves, right? Like so just tell us about all the kind of dream like scenarios and interaction patterns that you are thinking of. And again, like there will be event happening next week, live event on YouTube, where we'll be talking more about interplay of the framework and the AI world. And that's all we've got for today, but enjoy the rest of the conference. Thank you.
Welcome back.
Yeah.